Hello everyone, welcome to Grade 12 Physics AP, Mastering Momentum in Minutes. In this video, I'm going to talk about two-dimensional collisions. So, two-dimensional collisions are very similar to one-dimensional problems, except that you need to split the problem into x and y components. And in all of these problems, you should know that the momentum in the x direction is conserved, as well as the momentum in y direction is also conserved. So you need to separate these components and do the momentum before collision is equal to momentum after. But you need to split those between the x and the y. So in this example, consider the drawing right here. In this case, ball 1, in which it is 10 kilograms, is traveling at 20 meters per second, in which it hits ball 2 of weight 20 kilograms at rest. After the collision, the two travel according to the diagram, which ball 2 is traveling at 10 degrees from horizontal, above the horizontal, and ball 1 is traveling 30 degrees on the other side of the horizontal line. So, given how it goes, what are the two objects' velocity after the collision? So, first of all, we need to separate this into x and y components. So in the x component, we know that the momentum before equates to the 10 kilograms traveling at 20 meters per second. So we need 10 kilograms times 20 plus the momentum of the 20 kilogram ball, which is 0 because it's not even traveling, it's at rest. And then it would equate to the x component after the collision, which is 10 kilogram times the velocity of ball 1 times cosine 30 degrees plus 20 kilograms times velocity of ball 2 times cosine 10 degrees, because that's the x component. So our equation 1, after isolating and timesing all the numbers, we would get 200 equals 8.66 V1 plus 19.7 V2. Now, let's look at the y component. We know that the y component before the collision is 0 because all of the things are traveling in the x direction only before the collision. However, after collision, we got the momentum in the y direction, in which if we were to set the direction up of the screen is positive and negative is downward, then we would have 10 kilograms times the velocity of ball 1 times sine 30 degrees minus the 20 kilogram times the velocity of the second ball times sine 10 degrees. And then if we were to isolate in terms of variable V2, we would have V2 equals to 1.44 times V1. So let's substitute equation 2 into equation 1. If we were to substitute that, we would have 200 equals 8.66 V1 plus 19.7 times 1.44 V1. And if we were to isolate V1 in this equation, V1 would equal to 5.41 meters per second. And if we were to solve for V2 using equation 2, because we already got V1 already, the velocity of ball 2 would equal to 7.78 meters per second. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.